Hey guys, so in today's video we're going to cover basic concepts regarding functions. So the first thing that we're going to see is what a function actually is. We're going to take a look at its domain and its range, and we are going to look at their asymptotes and how to calculate them. Hey guys, so today we are going to start covering functions, specifically recognition and domain and ranges of these functions. And I think it's very important, since it's the first video about functions, to delimit very clearly what a function is and what is not a function. Any kind of drawing that you can make on a graph follows an input-output system. So if your input is going to be whatever number, that means x, you will go through the expression of the function, which will be a real machine, and then it will come out as an outcome, f of x. We usually simplify f of x to simply y, because normally we always use the y for the y-axis, not the f of x axis. So that's easy to understand. Not everything that we can do in this input-output system is actually going to be a function. There are certain rules that we have to follow to determine if something is a function or not. So for example, imagine that we have a sine or a cosine function, which would more or less look like that. I'm not Da Vinci, so don't criticize me. So this is a function. Why is it a function? Because for a single value of y, we can have one and more and more and more and more values of x. So that means that for one value of x, or an indefinite amount of values, we have a single value of y. However, what would happen if instead of having a function that looks like this, we had a line that would look like that? In other words, the inverse of a trigonometric function. Well, technically what we would have is an input-output system where we would have multiple values of y that would compute for a single value of x. And this is a very clear diagram to say this is a function and this is not a function. So in order for it to be a function, there can only be one value of y for each value of x, but not the other way around. And yeah, that's basically the main criteria to determine if something is a function or not. Also, another way we use to determine if something is a function or not is basically a direct translation from this, which is called the vertical line test. It's basically using a vertical line and moving it around the drawing. If at some point the line touches two or more points of the same line, that means that that set of points is not a function. So for example, if we ignore the red part here and we only take into account the blue part, and we move the vertical line across, we will see that it always only touches one point at a time. However, if we use only the red line, we will be touching no points until we reach here, and here we will be at each time touching infinite points. Therefore, it's not a function. We are now going to advance to more important tools, which are domain and range. So when we are in a function, we can also delimit how a function behaves based on where it goes through the x-axis and where it goes to the y-axis. So now we're going to take a look at what the domain and the range is by looking at a function. So let's just take a look at a random function that I'm just going to draw. So imagine that we have a function like that, and they ask us for the domain of that function. So the domain of that function will be the reflection of that line on the x-axis. So we will include in the domain all the intervals where the function exists. So I'm just going to say that here on the x-axis this is a, and here on the x-axis is b. So I'm just going to say that the domain here for x is between a and b. And if they ask us for the range, we would just say that it goes from here, because we're talking now about the y-axis, up to here. So let's just call it C and D. So then it will go from C to D. Now notice that I have used squared brackets. Here, squared brackets mean inclusion. Now it will not always be the case, because sometimes a function will tend to a certain value, will get extremely close to it, such as the case like asymptotes, but it will actually never reach that value. In this case, to express it more easily, imagine that we have a very similar function to this one, but instead of having this, we have something which is like that, which basically represents what I just explained before. Just something that really tends to a value but never really reaches it. An easy way to represent it would be to just revert this squared brackets. So it would be something like that, and then this thing would happen for the range. But there's also another notation that we can use that is just the simple circle brackets. So this is technically the same as saying circle bracket A towards B, circle bracket, and for the domain it would be circle bracket C towards the circle bracket. We're going to first see, without drawing the function, to actually see how the range and domain will be based on just the information that we get here. What we need to know is that range and domain basically means the function exists under these sets of values. So then the first thing that we need to do is obviously look where the function will not exist. That's where we have uncertainties. So, for example, if we have any kind of number or expression divided by 0, that will be an uncertainty, because something divided by 0 doesn't really give any result. And then also, if we have the square root of a negative number, it will not give a result because it doesn't exist unless you are talking about complex numbers. And then also logs of negative numbers will not exist because of the definition of logarithms. Now, let's take a look at this example. F of x equals 1 over x plus 3. This has a structure of a over 0, so we want to know where the bottom part is going to be 0. Well, so then we take this part, x plus 3, and we equal it to 0. We will see that x will equal minus 3 for the denominator to be 0. Then we will know that for the domain, it will go from minus infinity to minus 3, and then from minus 3 to plus infinity. And please note that the minus 3 will not be part of the function. Any other point will be, but except 3. So that's why we call it union, and then we include these ones. And this will be for the domain. Now, let's look at another example, which will be this one. And this one actually deals with horizontal asymptotes. The one we just dealt with deals with a vertical asymptote at minus 3. Now, if we have this one over here, we will see that we have horizontal asymptote where this is 0, which will be, we add x equals a half. And then for the horizontal asymptote, we just need to take these two values and we divide them, and we will get 3 halves, which is 1.5. So that means that we'll have an asymptote at y equals 3 halves. And that's also an important way to visualize this, because then you can say, okay, so the range in this one, because horizontal asymptotes affect mostly the range. The range will go from minus infinity to a half, and then from a half to plus infinity, excluding the 1.5.